exam around the corner. So let's study.
For real?
Yes.
Okay,
Come on,
fine.
come on.
Let's go.
Let's go. Muhammad, what are you doing?
I am studying differentiation today. So, study together. Hey, do you know what differentiation is? Differentiation is derivative of fx with respect to x to find the slope of x. There are 6 techniques of differentiation. First is constant rule, second is linear, third is power rule, fourth is sum and difference rule, 5 is product rule, 6 is quotient rule. So, let's try some questions.
Hi and Assalamualaikum. My name is Adam Krish. Today I'll show you guys how to solve for question 2. For question 2, we have 2 parts, A and B. Now let us start with question 2A. Question 2A, we have y is equal to 3x power 7 secant x minus 9. In this case, we can use product rule and chain rule. So the first step we have to find is derivative. For u, we have 3x power 7. U prime, we have 21x power 6. V secant x minus 9 and V prime we have secant x minus 9 tan x minus 9. Why 1? Because x is equal to 1, 9 is equal to 0 because it's a constant. So the second step, we have to use a product rule. So the equation for product rule is dy over ds uv prime plus v prime. Then we just have to subtract all the value that we get into this equation. So we can just stop here or we can just simplify. So I will show you guys how to simplify. So to simplify, we have two same factor and that is secant x minus 9. So we just have to factor that out and put in front because when we multiply inside the bracket we get the same equation. So then as you can see in the bracket we have two common factor, so we just have to factor that one out too and we'll get the final answer is dy over ds is equal to 3x power 6 secant x minus 9 x tan x minus 9 plus 7. Okay, that's all from me. Thank you. Now let's move on to part B. Okay, now let's move on to question B. For question B, we have y is equal to 6 plus 5x over tan x. Here we can use quotient rule. So the above one we have u and the below one we have v. So we have to find its derivative just like a previous question. For u prime we have 5 and v prime we have secant square x. So the equation for quotient rule is dy over ds equal vu prime minus uv prime over v2. So we have to subtract all the value into this equation. So we will get dy ds is equal to tan x 5 minus 6 plus 5x secant square x over tan square x. So then we have just to multiply all the number in the bracket and then we will get the final answer, and that is dy dx equal to 5 tan x minus 6 secant square x minus 5x secant square x over tan square x. Okay, now let's move on to the question 3. Okay, bye bye.
Okay, so we will answer question 3 that is given y ln 5x negative e to the power of 9x minus 4 plus sin times 3y equals 10. Find dy dx using implicit differentiation. So first we need to split this equation into 4 parts. First, a equals to y ln 5x. First we need to differentiate this. So this we need to use product rule. First we need to use u equals to y and u differentiate y equals to dy dx. After that we will differentiate ln 5x. When we differentiate ln 5x equal to 1 per 5x, and when we differentiate 5x equal to 5x, and we will times 1 per 5x and 5 it will equals 1 per x, and then we will use product rule where u y times with v prime equals to y 1 per x plus ln v ln 5x times dy dx. After that we times like normal, and then we will get y per x plus ln 5x times dy dx. So next, b equals to e to the power of 9x minus 4. Differentiate e is still the same as above, and we will differentiate 9x minus 4 equals to 9. After that we times both of them together equals 9 e to the power of 9x minus 4. Next, c equals to sin 3y. We will differentiate sin 3y first, where it will become cos 3y, and then we will differentiate 3y and will be 3 dy dx. We will time most of them together. It will become 3 cos 3y dy dx. We will differentiate d equals to 10, where differentiate will be equals d prime equals to 0. Then we will put all of them together, where a prime equals to y per x plus ln 5x dy dx minus b prime minus 9 e to the power of 9x minus 4 plus c prime plus 3 cos 3y dy dx equals d prime equals 0. Then we will put the equation that have dy dx on the left, the equation that have dy dx to the right. We will factor dy dx, where dy dx will times in bracket ln 5x plus 3 cos 3y close bracket equals to 9 e to the power of 9x minus 4 plus y per x. Then we will transfer the ln 5x plus 3 cos 3y to the right, where dy dx equals 9 e to the power of 9x minus 4 plus y per x divided by ln per ln times 5x plus 3 cos 3y.
Assalamualaikum and hello, my name is Muhammad Daniel. So today I'm gonna explain about the question 4. Question 4, we must use the linear approximation to find the estimate value of the 6th root of 4095.99 minus 2 over square root of 4095.99. So the given value for this question is 4095.99. After that, we must search for the initial value, which is the closest integer, and we get 4096. And after that, we must choose the delta x, which is the given value minus initial value. We get negative 0.01. Step number 2, let fx equal to the 6th root of x minus 2 over square root of x. And we change the form, and the final answer, we get x the power of 1 over 6 minus 2x the power of negative 1 over 2. So we must derivate the equation, and we get 1 over 6x, 1 over 6 minus 1, so it become negative 5 over 6, and negative 2x must multiply by negative 1 over 2, and we get plus x negative 3 over 2. So we change back to the simplest form, and the final answer, we get 1 over 6x the power of 5 over 6 plus 1 over x power of 3 over 2. So let's continue. To find the estimate value, we must use the formula of linear approximation, and the formula is f initial value plus delta x equal to f initial value plus f prime initial value multiplied by delta x. So for this equation, it's really easy. You just substitute the initial value, which is 4096, to the equation, and we get the whole equation here. And the estimate value from all this equation is, for the first one, 127 over 32 plus 131 over 7x6 432, and multiply it by negative 0.01. So for the final answer, we get 3.969 and change it to 3 decimal value. So I think that's it from me, and thank you. So in conclusion, this exercise demonstrates understanding of differentiation by using multiple techniques such as power rule, product rule, and using derivative for linear approximation. By applying this technique, we as a group highlighting the importance of calculus in analyzing the behavior of complex function. This analysis function allowing us to explore mathematical concepts deeply.
Okay, that's all from us, and thank you for watching. Bye bye.